Hi everyone, and welcome back to your YouTube channel, Tier Innovation. In this video, we will talk about the 12x12 Standard Truss and everything that is technical about it. Alright guys, so today we're going to discuss about the 12x12 Standard Truss with Luke.
Hi guys.
And I'm going to start first, and I'm going to introduce you just to see why we consider it a standard truss in the show business or any industries. So this is a 12x12 standard truss. This one is a plated one. I'll go back. I'll go later on plated and spigots. But the way we use it, we consider it like a light duty truss since it's a 12x12. So you can use it on pretty much anything. So lighting gear, video, sound, little grid if you want. You can be as well on scenic. You can hang some decor, or it can even be curtains. So it is really a truss that is multifunction.
And it's shallow as well. So.
And very shallow. Yeah. So when you can use it more on like a small venue, so hotel, congress venue, and many more places that as well have a limited weight. So let's say your roof can only take, I'm just going to say a number, let's say 5,000 pounds of weight, but this truss can be a better solution because it weighs lighter. And before guys, I'm going to go with question to Luke, just so about everything that is technical on the truss. I'm just going to do a little introduction on more specific details of the standard truss. So in a way, you got two models, two basic models. So you got the plated one, like this one we have here. And at our team at Tier Innovation, we design a new kind of plate, so an extrusion that make it more slicker, if you want. And you have the spigots. So these, I'm pretty sure most of you know, spigots, or do we have other names for that? No, it's pretty much spigots, yeah. So that's usually goes this way in the truss. So you pin it together, all that stuff. Pretty sure everyone knows. So that's kind of like the two basic of a standard truss. After that, you got different models. So it's just gonna go on the diagonals. So like this model we have right here is a truss that have diagonals on the sides, and top and bottom. It's just 2-inch tubes that goes, and we call it like the Princeton truss. So that's how we call it at our company.
We have different models on our website.
Yeah, and we have different models. There's some that goes with four diagonals all around. There's plenty models, and that's kind of like the North American standard. In Europe, it's pretty much the same, but it's in millimeters, right?
Yeah. And often you will have a conical spigot instead of
a spigot. Yeah.
We also do those kind of truss. Innovation, but most of it it's plated and spigot.
Yes. So now, guys, we're gonna go on the next section. I'm just gonna ask Luke some question, and I'm pretty sure you guys will like it because he's gonna explain to us all the details that we don't necessarily know when we work with the truss.
Yep.
So, Luke, can you explain how a chart of 12-12 is derived?
Yeah. First of all, let me explain you that every once we build a truss here at Tier Innovation, it always come with a sticker on it with the capacity chart. You will have like basic information on capacity on the sticker, and also on the website you have all the details of the capacity chart. And what the capacity chart will give you is the weight of the truss and also the strength of the truss. So basically a truss is a beam acting in flexion. So, and it's simply supported where you have your pickup point. So on the capacity chart, you will have like 4 different span, how much load you can put on it. So you'll have the single point loading, 2-point loading, 3rd-point loading, and also uniformly distributed load. So on this chart, you will have the theoretical displacement. So you can have an idea if you hang that amount of load on it, you will see how much deflection you're supposed to have with the different span. So you can basically design your shows based on your pickup point and how much load you will put on. And your question was how this is derived. So we will take all the materials and pins and bolts that we have on a truss. We will take all the allowables from those material pins, etc., and we will put our safety factors on it.
And the safety is usually 2 or?
It's usually 2.17 on the yield strength. So this is based on the aluminum design manual and ESTA as well. So with those safety factor, we will see what is the weakest point on the truss, and then derive a capacity chart based on that weakest point. So because we don't want to overload the truss and have a permanent deformation. So like I said, everything is calculated on the yield strength. So and then you will have different weak spot depending on the model of the truss and depending on the connection of the truss. So a bolted truss, a plated truss with bolt, is not the same weakest spot as the spigot one and as the conical one. So basically that's how we calculate a chart.
Copy that. That's cool. Thank you. And so my second question is, what are the weak points on the truss? So I know you just said a little bit about it, but what it actually is on the truss.
Yeah, let's start with the plated truss. So what we will check on a welded plated truss like that is the maximum stress at all the welded location, because we know it's affected by heat. So because of that, the properties of the aluminum will be really smaller because it's affected by heat. So we'll take a look at all those locations. We will take a look as well as the buckling of the diagonals, because since the truss is in bending, you will have some diagonals that are in compression. So we don't want that to break in buckling. We'll also check all the tension loads in all the diagonals, the main cord, as well as the shear strength, the shear out of the bolt at the plated.
Okay, so
with
this location, yeah.
Yeah, this location. So because when you have a big span, all the loads will pass through the boat to transfer to each one of your small piece of truss. So the weakest point for a bolted truss like that will be near the head of the boat.
Okay.
So that's where you'll have the most stress, and so the boat will try to either the boat will break in tension or in shear, or the plate of the truss itself will deform.
Okay.
So that's the critical location for a plated one.
And it's very important that the bolts are very tight.
Yeah.
Because if you're kind of loose, it's just gonna extend.
It's important not to over torque the boat, but you need to have a complete no
contact.
separation.
Yeah. Okay.
Yeah. So that's the weakest spot for a plated one. For a spigot truss, the weakest spot is actually the spring pin in the tube. So let's say we install this spigot here. You will have at least 2 spring pins. So we will check the same thing as a plated one, except for the connection. We will need to check the double shear of the pin itself, the conical pin, not conical but tapered pin.
Mm-hmm.
And we will need to check the shear strength of the spring pin, both spring pin that we put there, and the bearing load of those 2 spring pins in the tube. So either the spring pin will fail in shear, or it can deform the holes that will be done in the tube. And habitually for a spigot truss, it's either the lug, so the male lug that will fail here in shear, or the spring pin holes.
Okay.
So depending on the thickness of the tube, and also on the height of the truss, it will be either the hole in the tubes or the
spigots.
The spigot, the male
Okay.
spigot. Yeah.
I just want to come back to you, Luke, about detail. You talk about the torque.
Yep.
And I know you said like not too tight. And just a quick, for me, sometime when I was on tour and I was working with plated truss, it kind of hard sometimes to have the time just to see if I have the right torque. Do you know what's the right torque we have to use?
I know during the show you don't have always a torque wrench, but the maximum torque to put on a truss like that is 130 foot-pound. So it's important not to overload the boat, because if you overload the boat, you create tension, residual stress in the boat, and then you will reduce the capacity of the truss. Yeah, because the boat is already pre-strained. So when you will put more load on it, you can overpass the safety.
Could it be a reason that's why the boat can jam sometimes when you're unloading everything and just you cannot undo the boat, you have to cut it?
No, that's not the reason, but that's maybe only because the boat has
moved a little
bit or something, because you have some loose in the, yeah.
Cool.
And actually the torque that I mentioned is for 5/8 grade 8 boat.
Okay. So no but it's the best boat we have to use though.
Yeah.
So the 5/8 grade 8. But okay. And so my next question will be, what are the main difference between a spigot and a plated truss in terms of strength? Because it could be, people can say the plated is stronger or the spigot is stronger. So what is the real in that?
Again, you have different model of truss, but let's say we compare a 12-12 plated truss with a 12-12 spigot truss. The spigot truss will be a little bit more
stronger.
Yeah. And that's the main reason, is because if we take a look here, maybe you can do a nicer.
I'll do a nicer shot. Yeah, that's for sure.
If you take a spigot truss and a bolted truss, so the distance between the bolted holes is smaller than what you will have center from the main cord.
Okay.
So, and the spigot as well will like introduce your you will have a continuity of the load, so the load is more direct. So and it don't have to go through the main cord, through the plated, through the boat, and back again in the main cord. So the path is more direct.
It's do a straight line. It does a straight line with the main cord.
Yeah. Okay. The straight line with the main cord, and also this distance is pretty important since it's a beam inflection. So like I said, the truss, the capacity chart is calculated with the pickup points. So minimum 2 pickup points where that's the span on the capacity chart. So this beam inflection like that, there's a big moment in the middle, and that moment, the more you have this distance, the more is bigger, the more it will reduce the load. So
on the weak points.
Yeah, on the weakest point, because you have a bigger distance to distribute the load.
Okay, copy that. That makes sense. And thank you for this one. And what does having a thicker main tube does on the capacity chart? So usually we go in Canada is more like schedule 40 or 80.
Yep.
And US is kind of the same, but in 2-inch tube. So what's the difference in those?
The main difference would be with the spigot truss.
Okay.
Like I said, for the spigot, you have the weakest point is the hole in the tube for the spring pin. So, and that weakest point is directly proportional to the thickness of the tube. So, more thickness of the tube you have, the more load it can take before deformation. So that would be the biggest difference. For plated, to be honest, it won't change a lot of things, because if you have a thicker tube, the weakest point will still be the hole around the boat.
Okay.
So unless you thicken the plate of the truss, there's no point putting a bigger tube there.
Okay, and it applies to 2-inch, because for us it's 1.9
it
inch.
applies to 2-inch.
2-inch, and it's the same
So
principle.
for the United States, you will have 2-inch and 1/8 the thickness of the tube, or 3/16.
Yeah.
So again, the 3/16 will be stronger for the spigot truss, but
for the plated, it doesn't change.
Yeah.
Copy that.
You will only add weight.
Yeah.
So yeah.
Yeah, and we did a calculation recently that since the tube is thicker, the plated is weaker. because it add more weight. So,
Yeah, that's it. So you have more of its self weight to transfer.
To transfer. And what is the difference between a steel and aluminum spigot? I know it's not really used on 12 by 12, but it's more used on the 2020 or sometimes 1616.
Starting for 2020 and more, like I said, if you have more 8, the stronger you will be able to put on the truss. So this will change after 20 by 20. The weakest point won't be anymore the hole for the spring pin, but might become the
spigot itself.
The male spigot. Yeah.
Okay.
So with the aluminum spigot, if it's made in 6061, this will become the weakest point. So there's standard in the US to put that in steel instead of aluminum. So that's why maybe you will see 12 by 12 with steel spigot as well. It's because past 20 by 20 you need the steel spigot. So some trussing company decided to have
all of them
in steel. Yeah.
Copy that. Okay.
So but before 20 by 20, for weight reason, you're better with aluminum.
With aluminum. Okay. That's cool. So that's pretty much all my big question.
Yep.
So if you guys have any other question about the 12 by 12 truss, just as usual, leave a comments down below, and we'll see what we can answer to you guys and come back with Luke's experience.
Yeah, I can add just a quick review on the 12 by 12 like that. And sometimes we will see truss in diamond. So hanging diamond, just saying that this is really not a good idea, because the truss is not made to work like that.
Yeah. So when you see this is made to go like this.
Yeah.
It's not made to go like that.
Yeah, and the main reason for that is because, like I said, everything is calculated to have your main tube, so main cord on the top and on the bottom. So like I said, it's a beam inflection. And if you put the diagonals like that, you will reduce a lot the inertia of the truss, and the capacity chart won't be true there.
But in a way, if you want to use a truss in a diagonal way, in a diamond way, if you want more diamond, you'll have to go by an engineer just to see if it's doable with the project you have, and if it can pass to the capacity you want to put on.
Sometimes, depending on what you will hang on it, it can pass, but for sure it needs to be checked by an engineer or the truss manufacturer like us. And that's something we can do.
Yeah. So
but it's a case by case.
It brings me a question. So because we think a 12 by truss like that, or just a standard truss, can be used on any structure that you want, but it's mainly designed or engineered as a straight horizontal truss, right?
Yeah, that's right.
If you do a structural thing, so let's say with legs and different setup, if we want, you'll have to go through engineer.
Yeah. Again, that's why you won't see any capacity chart on a cube, so a corner cube, because depending on what span you will have on one side and how much, a cube is 6 face, so maybe you will only use 2 face or 3 face, or so it would be very difficult to do a chart for that kind of structure. So again, the cube habitually here at Terrio Innovation, we will ask the client if he has a funky structure to come and see us, and so yeah, and we'll do a calculation for that. Same thing if you use a truss as a leg. Again, the capacity chart won't give you any capacity for the leg, because again, it depends on what you put on the top
of it.
Yeah, the top of it, and how is it support. Do you have guy wires going on the ground supporting it laterally or not? And so that's something we can do, and for sure any engineers can calculate.
So it's something that's more specific. So if someone really has question about his project, he has to see with his people, or he can see with us if we can answer them this question.
And also all the charts are not made in, and that's not only Terrio Innovation. It's all. I think I talked with all the manufacturer. It's not dynamic loads or fatigue loading. It's only static loading that we give on the chart. again, it will be too much work and too much different scenarios to put fatigue loading and dynamic loading, etc.
So it's really basic.
Yeah.
In a way. Okay. Cool. So, guys, again, just write to us if you have any question. And thank you, Luke, for sharing your knowledge about the truss.
No problem.
Cool. It's really
Let's
cool to
see,
know.
you in another podcast.
Yes. Yeah. So thank you, guys. I'll come back to you.
Yeah.
All right, guys. I hope you like our discussion, Luke and I, about the 12x12 standard truss. In the next videos, we will talk about the 16x16, 20x20, and others subjects that will come later. We're gonna cover as well, just a little bonus today on this video, is we're gonna do a video about the manufacturing on all the weldings, but it's very important, guys, to remember that the welding is very important on a truss. If the welding is not well made, it could create a weakness to the truss that we don't necessarily see all the time. So it's very important sometimes if you see like defaults or something like that, to just raise a flag and see if it could be fixed. So it's just a little bonus on this video today, guys. And it's very important. Quality equals safety. So guys, remember, subscribe and leave a comment down below, and we'll see you on the next one. Thank you.